Currently driving.
Okay, that's okay. But you had a question about the TNL system, right?
And yes, and the sliding filament theory.
Okay. Anything specific on the TNL system or generally?
Just generally, it's just hard for me to grasp the concept. I have a.
Oh, that's a good question. I had the same question.
Okay, so let me share this with you. So while you were there talking, let's see if Catherine comes back, or otherwise we'll just do it on our end. Can you see my screen?
Yes.
All right, good. So we're looking at muscle, the initial, what the terminology is, a little bit, what the characteristics are. That was all okay, right?
Mm-hmm.
The different types, that was all right?
So different types is okay.
All right, good. And then we get into the nitty gritty a little bit. So
yeah, the nitty gritty.
I know. So what I want to look at here is first, the thing, I think the one thing that it's hard for me to appreciate in the muscle is the fact that you have a big muscle like a biceps or so.
Mm-hmm.
And then actually that's even smaller. Let me see, where do I have a picture of that surrounding stuff? Let me see. I might have to share this differently. I think I have a picture of the layers in the stop sharing. There we go.
But that little segment, was that of that blow up you had of the sarcolemmas encasing the myofibrils? Is that just a small segment of the whole?
Yeah. That's what I want to really get. That's, I think, some of the first question marks that come up when I look at it. Let me just see if I can get this bookmark off. And then we're looking at muscle physio. Let me see if I have a better picture in here. I've been working on the hearts, not the quiz though. I've been working on the heart and the blood and all that. So I'm like, let me go back to this.
Oh yeah.
Because it's actually a lot of work to get these done. I really love doing it, but it like takes me way longer than I think it should take. I'm like, ugh. Anyway, this is what I wanted. This picture. Can you see this picture?
Yeah.
You see the whole muscle. So you got the whole muscle is your biceps, okay, and that's the muscle, and then inside that muscle you got segments. These are called fascicles. See here. Then they take one of those fascicles out, and then they blow it up, and it looks again like it's a whole muscle.
Yeah.
Right. It's the thing, but it's one of those down here. And then you take one of those fascicles, and inside the fascicles you got individual muscle fibers.
And
then this one is a muscle fiber then here. This whole thing is a muscle fiber. So take this and then make it smaller into a muscle fiber. And a muscle fiber is one cell. So it's one cell that goes from one bone to one bone. So the biceps goes from the shoulder to the elbow. That's one fiber long.
That's one fiber long.
Yeah, they fuse together when you're as an embryo.
But is that one cell?
That's one cell. One fiber is one cell. Correct.
Oh, okay. I thought they were maybe connected by like the desmod.
No, the cells themselves are one cell is a whole length long.
So they can be that long, that cell.
Yeah. And what happens, that's why they're called multinucleated. They have more than one nucleus.
Okay.
They fuse together. They're multiple cells, and then they fuse together in embryonic stage. And then the nucleus stays, but the cell becomes one whole long thread. It's like a thread at that point, right? It's that small. And then you open the thread up, and inside the thread, you even have smaller things, and those are called myofibrils. And those are where we then arrange the thick and the thin filaments and that sliding filament theory.
That's where the actin and the myosin, that's where they actually reside, inside those myofibrils.
Inside the myofibril is where those actin and myosins are. And so that's how small we're going to get. And then when we want to study how does a muscle contract, what we do is we take one of those myofibrils and we chop it up, and then inside there are these different lines. And let's go back to whatever I had up here, I think. This one. And so then this is a myofibril. No, this is a cell. Then this is a myofibril here. Okay, so we're in the same place again.
Yeah.
And then what we do is we take one of those segments, one of those small segments, and that then is what we study. And so then that becomes one of those. All right. So that's one myofibril, that's another myofibril, that's another myofibril. And then together, all these connected, it becomes a muscle fiber. Not a muscle fiber.
Muscle fiber.
And
Okay.
so then that's a muscle fiber.
So the TNL systems is just multiple myofibrils functioning together?
So the TNL system refers to the system that brings the nerve impulse deep into the muscle. And that's that yellow stuff here. That's like nerve impulse stuff that goes down. The nerve impulse goes down. So the nerve, that's why it's yellow. Everything in the body that's yellow is kind of nervy, if you can have it. So that's that part of the triad. That's the T-tubule. And so that brings the nerve impulse down, which initiates the muscle contraction, but it does that by secreting calcium deep into the myofibril, where then those actin and myosins are. And the calcium resides in this sarcoplasmic reticulum, the blue stuff, which is endoplasmic reticulum, but modified endoplasmic reticulum. So it becomes a bag of calcium. And so it holds the calcium. And when the nerve impulse comes down, that myofibril, that T-tubule, the SR, that blue stuff, the sarcoplasmic reticulum, releases all the calcium deep into the muscle cells. And that's when the actin and the myosin start doing their work together. So you need, does that make sense so far?
Yes.
And I forgot, why does it say L? Where does the L come in? I forgot the L word, but that's that triad is the system, what it refers. I know it's been 2 years since I've been teaching classes, like some of the stuff. But that's the TNL system is those two, that triad that refers to that. So the fact that we bring a nerve impulse down, because the muscle, I have it down here somewhere, the muscle needs to be innervated by a nerve, the skeletal muscle, and the nerve says, oh, I need to contract. I got to move that leg or that arm around. And so that nerve impulse from the brain is what goes down deep into the muscle and all the way down to the myofibril level. And then all it really does by sending the signal is by activating the release of calcium. And then once that calcium is in there, then we can go to the actin, the small one, the thin one, and the myosin. But let's actually just go right here, because that's really the meat and potato right there. So, and you ask, if you ever have your question, just interrupt me, okay? Both of you guys, because
I'm sorry, sir. So the TNL system is just a small portion of the bigger sliding filament theory. Is that correct?
It's part of it. Like, what happens is, so when you look at the myofibril on the inside, you got these two fibers, right? You got the thin filaments and you got the thick filaments. Do you understand that part?
Yes.
Good. And so then from there, what we need to understand is the fact that the thick filament, the myosin, which is this myosin head, is this yellow thing, this red thing here, needs to attach at a specific place at the actin in order to function properly. But a part, like a little smaller thread, covers that active site, they call that specific place over. And if the calcium is not present, that is covered, and then the myosin head cannot attach to that. If the actin is present, it moves the calcium present. If we want to contract, the calcium moves that thread to the side. You can see it here in a cross section. It just kind of like moves this thing down, and then the myosin head can attach to the active side on the actin, and then it can do its work, which is basically contract.
Wow. It's like
So
key.
far, so good.
Calcium's like a key.
The calcium is the key, right? It's a passive part, but it's the key. So far, so good, Catherine?
Yes.
And then we can get into the filament theory, because then we have this moment when the myosin head can attach to this space at the actin that gives, it's like a magnet, right? If the magnet is free, it can attach to it. And then the ATP comes into play. So the ATP starts here. When you take ATP here, the ATP, so what happens is that the head is bent in an angle. The ATP makes like, it cocks a spring, like it loads the spring up and it makes it go upright. And that makes when the ATP is used. The ATP is the fuel in the body, right? And so the ATP hydrolysis means ATP becomes ADP in the phosphate. But what that means for us, we have a burst of energy that we can use for something. And we use it here by turning that head of the myosin upright and sort of cocking that spring. And then, so that's the active part, right? Where we need the energy. But then once the active side is free and the head can attach to it, passively the spring lets go and it pushes the head downward, which then moves the actin a little bit forward, very tiny amounts in one direction, and which basically means the actin and the myosin moves past each other a little bit. And that's what's referred to as the sliding of the two filaments.
Mm.
And the more that those come together, when you go back to the picture where you have these lines, the A band and the Z line, you know, at the Z disc, at the end of the little small segment of the myofibril that we studied, the Z disc is where the actin anchors together, and that's a stable place. And the myosins come from the inside, from the M line outward towards the C disc. And when they pull on the actin, it pulls from both sides and it brings those C discs closer together. And that over, you know, if you make that and extrapolate to a big muscle, that contracts a muscle. Make sense?
So
Now
that
it
M line,
does.
I'm sorry, that M line is where they're anchored.
The M line is, we call that the midline, as in M, right? And that's the place where the myosin, the thicker filaments with the head that actually does that active work, the ATP, that's where they anchor in the middle. And they reach out towards the Z lines, which is the outside of that, you know, one segment of a what is it called? A myofibril.
Yes.
And that's where the actin anchors. And so when you have a middle anchor and an outside anchor and you pull them towards each other, it shortens them also.
Okay. So in a bicep, that there's an M line at the origin and then the M line at the insertion.
No, there is an M line all along the muscle. There's
all along
M lines. There is a gazillion M lines all along the muscle, and every little segment contracts a little bit. And as a whole, the muscle then contracts as a unit.
Okay.
Very intricate that way.
So then the motor unit is would be shown in just along one myofibril?
No, the motor unit, then you go back to the big muscle, to a muscle. So when you think about, and you take the muscle apart, you have the right? You have the whole muscle and you have the fascicles and then you have the fibers. So the motor units go to, so each muscle gets innervated by multiple different motor units and they go to different muscle fibers, or probably fascicles even at the end of the day. And then when one nerve fires, all of those contract at the same time.
Got it.
When another one fires, those contract. If you want a lot of muscle contraction, really strong, like you kicking a soccer ball or something on the quad, you want all of them contracting. Right? Make sense?
Yeah. So what would be an example, like how you have a motor unit consisting of a few muscle? Would that be like something like the muscles in the, like the eyelid?
Yes.
Would be like.
So you have motor units, in one motor unit only innervating a few fibers. You get fine motor control, but generally not as much strength.
Mm-hmm.
And if you have one motor unit innervating many, many fibers, you get less control, but more recruitments of more strength.
Okay.
So that would be a quad or something.
Okay.
Very good questions. Keep coming. Everybody's going to like those because I'm recording it.
Yeah, that helps. That helps to put it in perspective.
No, that's good. That's what we're missing because we don't have class. If you can do it like that, that's perfect. Is that any other questions coming up right now? Anything, Catherine? Are you still here?
I'm still here. Your explanation is perfect.
Oh, good. And you said you haven't done the trunk, right? So we maybe want to do a session a little later about those.
I haven't gotten started, but I mean, I've read ahead, but I haven't watched the YouTube videos. But if Bruce has and he has questions, I'm all ears.
Okay. Yeah, and I'm happy to do another session later too. I love talking about this stuff, as you can tell. I don't mind. It's just a matter of finding the right time for everybody, and I can be somewhat flexible. So if that's all we have so far, is you have anything else, Bruce, that's coming up right now?
No. I was gonna try to knock out the coloring exercises for this week, the label and coloring.
Okay. That
Yeah.
sounds good. Yeah, do that, and then shoot me a text, everybody, if you want to have another session later on this week or on the weekend. Saturdays is a little hard. I have patience, but Sunday I have some time, or Monday after class or something like that too.
Okay, so if I do have a question regarding the trunk, should I just reach out on Pronto again?
Yeah.
Okay.
And if I space, I should catch it, even if it takes me, I put the phone away at night. So you can text me anytime. It doesn't matter.
Wonderful. I really appreciate you going over this.
Yeah.
No,
this
I'm
is
glad we
so
can
helpful.
do this. I'm glad it's helpful. I think we should do it more, a little bit more frequently because this is some good stuff. If you can integrate this properly, I think this is some good stuff. And this is more understanding this part. I'm not going to be fully testing you on past the quiz on that or past the questions. But it's good to understand that fundamental way of how it works. But if you understand what we just went over, and if you have to even put in the terminology afterwards, that's totally fine. Okay, this is more a question for me, for you to maybe less the terminology, get that exact, but more like how it functions to understand the process. Okay.
Well, and I think by you specifically saying that it's literally the head sliding, it just pulled it all together for me for the sliding filament theory.
I'm telling you, this stuff, you should watch, if you haven't, you should watch the cell video that visualizes it. I think I have it on the cell chapter in the beginning, or I even have it in one of the booklets in the background, in the backside on a TED Talk. Because if they visualize how a cell divides, how it pulls apart, and it's physical. It's like what I just talked about with the head movement. It's like that physical. There's like molecules that have feet that walk. Huh. And they try to make it as literal as it is as possible. And to me, that's very helpful, because visualizing it creates like that kinesthetic or visual step to me understanding it. And it's not just a word, Yeah, if that helps, I urge you to watch. It's like a 10-minute thing. It's very short. It's not long. It's a TED Talk. I forgot who it was by. I can text you the stuff if you guys are interested in that.
Yeah.
It's by, I think it's Animation Unseen Biology. If you have the booklets, I think it's off. In the booklets on the back page, in the bottom row on the middle, that's the one. If you don't have the booklets, shoot me a pronto. I'll send.
Wait, is that on booklet 3?
No, booklet 1. Sorry, booklet 1.
Booklet 1. Okay.
On the cell. Yeah, it's about cell division, but it's still the same, like trying to visualize some processes in biology that it makes more sense to us. And I think that's what's important, because the stuff is in our body, it should be not that hard to understand, really, if you think about it. But scientists like to make it complicated,
Yeah.
But then we can say, look, you don't understand.
Well, I will definitely look it up in the booklet in the bottom row.
Perfect. Yeah, do it. Otherwise, shoot me a text. And then again, yes, send me questions over we can do something like this. Even if one person is on the call, we'll make a little video. Everybody's gonna appreciate it.
I've got a question relating to the neck muscles real quick. I know it's a little
Yes,
bit
sir.
like off topic, but
No,
the
it's-
scalenes, how can you find them on your own? Because I understand that they're under the layers. Is
well,
there, could you demonstrate on you like how you would
yeah.
locate them? And
Very simple. One of the things you can do to feel muscle is by taking the action and reversing it. Now I don't know this. It's always hard for me to know the words of the action. Hold on. I know how they go. I mean, the scalings are right here. If you take the clavicle, the collarbone, and you go from like the center outward, some like here,
Mhm.
and you go down, that's scaling stuff. If you go close to the middle, you get the SEM. So if you oppose a function, if you oppose the action, like you turn into it, your sternocleidomastoid will stick out.
Mhm.
That's like here, and right below that and next to it will be the scalings, right in here. And you can palpate them, and if they're really stiff, you get a little nervy feeling in there if you go deep.
Oh yeah.
And they go from there up, they go actually underneath the clavicle into the first and second rib. And then they go up into here into the front of the vertebra. And it's hard to feel that unless it's sensitive. Like when I test the muscle on a patient and it doesn't work right, then the attachments are sensitive. Then I kind of know I'm working on that versus, one like next to it. But you have a lot of muscles that go in there. But it goes into the anterior tubercles of the vertebrae in the front. So you got like 3 layers. And they call it scalenes because they look like the scales on a fish. They're like 3 layers that come down, and in between the nerves come out that go into the upper extremities. And so very often you have people that do a lot of lifting or have whiplash or do a lot of holding up and typing kind of thing, and they get really stiff here because they hold all this up, and the ribs generally move a little bit back and out. And then these get stiff and the nerves get tight, and then they get arm symptoms. So that can be a problem, like radiculopathy, like shooting pain in needles or stuff like that. And then sometimes then you think it's a carpal tunnel, but carpal tunnel can be multiple places, and one place it can be is up here.
Ah, okay.
Yeah, and other places in the elbow, because when you type, you push the palms down to type, and that's uses a muscle that turns the palm down very heavily. And we'll learn that muscle. We'll go through that too.
What's the antagonist muscle for that group?
For the scalings?
Yeah. Or you just have to stretch them?
I would think somewhat the trapezius, because it's, it sort of does this kind of motion. The trapezius, and then probably the splenius, or maybe the semispinalis a little more even. That's a good question.
It's difficult for me to really kind of conceptualize them because there's so many layers.
Yeah, it's really hard.
Yeah,
that stuff takes a while. Takes me a while. I mean, believe me, I've just really understood, like in the back, that splenius into semispinalis when I made the booklets. And I've been around this stuff since I don't know when, forever. Because I started studying massage as a teenager. But so you just learn layer by layer. So don't worry if it's really tough. But right now, if you can differentiate this in the front, like the SEM that goes down here, if you can have that as the most superficial layer, and the most superficial layer, it moves the stuff around. Those are the ones that move things around. The deeper layer, they hold things more together. They don't move as much, right? Because it would make no sense if the deep ones move the neck around. What would those do on the outside? So the outside layers, the superficial layers, they move things around. The deeper layers stabilize things a little bit more. And so in the front of the neck, you kind of have the SEM coming from up here, going down here. So that's a good one that moves. In the back, the most superficial is the trapezius on the outside. That's like this part too, goes all the way down here and all the way up here. and then down, into the back, into the midline, even all the way down the thoracic spine. So that's a big one. But in the neck, it's sort of an antagonist to that SCM in some ways. And then below that and on the side, you got then the scalenes. And that sort of does a little bit deeper motion, like these kind of motions, and helps the SCM, but it's a little more contracting. And also raises those first ribs when you take a really deep breath. That can also be a reason why they get tight. And in the back, you have a deeper layer underneath the trapezius that goes from the outside inward and then from the inside outward a little. And those are your semispinalis and splenius. And I don't worry about you studying those at all. You don't need to worry about those. But those are in the booklet. If you have the booklet, you have those on page 15 in that book. And then on the back, you have one more deeper layer right underneath the occiput. And those are the suboccipital layers. Those are interesting for clinical purposes working. Those are like really, really deep. It's really hard to feel those. If like somebody's face up and you have your hands sticking up underneath here and they sort of relax into you right underneath the skull under the occiput, then you can really get into those and relax those. And those are interesting to really do deep relaxation because they can be involved with things like back pain or even feet. When I work those up here, sometimes people feel it in the feet, in the sole of the foot, because fascia, the whole back is all connected with fascia. And so that's when they become interesting. And so that's in the back. So you got the trapezius, the second layer is the semispinalis splenius, and then the deep layer is the suboccipitals. In the front, you have that SCM, and then on the side, you have the scalenes, and then deep, you have these longus coli, which are in the booklet. And I think I talk about it briefly in the video too. And those are really right on the bone. Those are really deep. You're not going to touch those unless you really go deep and right next to the trachea and work the people, clinically, if you work on that. But those muscles I put in and I want to talk about because when you have whiplash, and whiplash is when you get, like you sit in the car and your headrest is up here, behind here, and your head is forward here. You get hit from the back and your head goes back. This motion of reaching back fast stretches these deep front muscles. And that's where that becomes, clinically an important thing. And so that's one reason why I do that, because, unfortunately, a lot of people get whiplashed. And then when that happens, I want to be able to talk to people about that, what's going on. So that's why I bring that in, but don't worry about studying it in terms of its name. Just know from your perspective, know that there's a superficial, that's the SCM, that one we study. And then the scalene is the one on the side, a little bit lateral, deeper you can find that, and that one we study. And I think the trapezius is in there, and I'm not sure what other one is in there from the next perspective. I don't think we're gonna, on the calling book, you have the semispinalis and the splenius, do you?
They're in there, and they're in the booklet, but
They're not on the list, right?
I don't think they're on the list.
I don't think so. I don't think I go that deep in terms of me wanting to remember. The ones I don't have on the list, I put in the videos and in the booklet, so so it gives you a bigger understanding of the situation a little bit.
Very helpful.
Okay, good. Yeah, bring those questions. Those are very important, and I think it helps, because I think, I'm a massage therapist, and then I became a chiropractor, and so I do a lot of biomechanics. And so that's my topic where I can teach. But I realize, having gone through all this training, a lot of things is actually not that complicated, but it has to be explained in a way that it sort of functionally makes sense. And it's not just a list of things,
Mm-hmm.
Yeah. All right.
Well, it's also helpful that your booklets have the muscles for the neck are the ones that aren't as deep, are the first ones we go over, and then the next page gets a little bit deeper and a little bit deeper.
Yeah, I try to do, because it is extreme. It is very complicated. And like when it comes to the feet, we don't even talk about the feet, because there's like 4 layers of muscles on the feet, the sole of the foot. When I have to study those, when I work on some patients, when I have to figure out which one is hurting and which one is not working right. And I have on my iPad, I have these lists that I made, these like pictures of layers, and I had to study it over and over, and I have to look it up. I can't remember these things. you know, it gets very, very, very vast. And so don't feel bad if it feels like it's overwhelming. It's supposed to be overwhelming. And so that's why it's like the booklet or the videos is the big structure. And then I want your study to focus on the list of what I want you to be able to recognize. And that's how you sort of slowly, I think, absorb the information. Does that make sense?
Yes.
Good. All right. Any other questions at this moment?
None for me.
Okay. What about you, Bruce? You good?
I'm good.
All right. Well, why about
I'll reach out on Pronto if I need.
Yeah, let's reach out. Give me some times when it works for you, and we'll find another time to meet. I think these are topics that are very important to have you guys have some Q&A sessions on and clarify, because it's really about understanding. The memorization is really secondary. Okay.
Thank you.
Thank you.
Thank
guys.
you, sir.
Thank you. Bye.
Thank you.
Have a
Bye.
good
Bye.
one. Bye.